It is Wednesday, my dudes.
3, 2, 1. Oh shit. He's coming back on, isn't he?
In this video, we'll see how to actually create the simulation input data files that I've used in previous videos. So there's KingsRockSim loaded up. You run the program because you can create these data files from within the program itself. Now, previously, I've entered 0 to match the key for the length dimension we want to use consistently. That's meters, and then 0 again for kilograms. That's what we're going to stick with for creating these input data files. And since we're not going to import simulation input data this time, you'll hit no for that, N, and enter. And then it will start asking you questions that it will use to build up that data file. So firstly, how many stages are in the rocket? We're going to use Alpha Centauri as a case study here. It only has one stage, so 1 and enter. Then, how long do you expect the flight to last? This is generally just used to set a recommended time step, so we'll select 1,000 seconds. It's very unlikely to last any longer than that. It's a small rocket. So it recommends a time step of 0.1 seconds, which we'll go with. So type 0.1 and enter. And now a description of these particular simulation settings. That will go into your simulation descriptors file. We'll just type Alpha Centauri and new settings. And we can look in that file later. Now, it'll ask you if you want to import rocket design data. In this case we will. In the next video we'll see how to create that file also. Here we have the simulation descriptors file, and there's set number 3 that's currently being created, called Alpha Centauri new settings. So we'll import the Alpha Centauri rocket design and then continue to build the simulation input data. We'll hit no for entering a value for the surface area directly, because that will be calculated from the Alpha Centauri rocket design file. We'll use 0 launch lugs again, it's not too important. Now, initial conditions. You need to enter a value for the downrange distance from the reference point at launch. Now that's typically 0, because you're going to be launching from your reference point. You also want your launch altitude above sea level, we'll go with 0 for now. And inclination of your rocket. In this case, that's measured from the horizontal plane in degrees. Now, typically, you want 90 degrees, you want to launch vertically, but in real life it's very difficult to achieve exactly 90 degrees launch angle. So we'll try to make it more realistic. We'll say 89.5 degrees in this case. Next, you need a value for the velocity at launch, that's typically 0, and the height of your launch tower. Now, the launch tower that we might be using is from a society called Aspire Space, and they have a launch tower that's about 15 meters long. That's this launch tower, 15 meters or 49 feet tall. So we'll enter 15 meters. Recall that since we selected meters at the beginning, every length dimension that we enter has to be in meters. So 15 and enter. Next, we're looking at the wind. So firstly, the mean or average wind velocity at launch. That depends on your launch site. So if you can't measure your wind velocity at the launch site, you can use a weather website and just look up wind statistics for a given location and time. So for example, currently in London, if we scroll down on this website, it shows you wind direction, speed and gust. So we'll pick one of these out at random. Let's say this one. So that's a mean velocity of 7 with a gust velocity of 13. Now in this website it was in miles per hour. For our program we'd need it in meters per second. But in the interest of time, instead of converting miles per hour to meters per second, we'll just use the numbers 7 and 13 and instead assume a mean wind velocity of 7 meters per second and gust of 13 meters per second. So enter 7 and then it will ask you your gust velocity and we'll use 13. And then the angle that the wind vector makes with your rocket at launch. So since this is a 3 degrees of freedom rocket trajectory simulator, we're only working in a 2-dimensional plane. We're either going to launch into the wind or we're going to launch against it. In this case, we'll launch against it, so we'll say the angle it makes with the rocket is 0 degrees. Next, we have stage information. Firstly, your payload mass. Normally you can just set that to 0. In the case of Alpha Centauri, it is currently 0. Then the propellant mass of stage 1, and it's going to ask all these questions for each stage in your rocket. Of course, with Alpha Centauri, we only have one stage. The propellant mass in this case, you would either get from your CAD model, your computer-aided design model, or from the mass budget spreadsheet, but we can just refer to our previously generated simulation input data file for convenience in this case. So the value is 0.9792, and that's kilograms, because again, recall we selected kilograms to use as our mass unit at the beginning. It will then ask you for the specific impulse. For Alpha Centauri, the Rickrock motor, that's 219 seconds. Your time dimension is always seconds for this program. Then the thrust in kilonewtons for Rickrock is 0.2028 average. Of course, this will actually be overridden by an engine file that we'll import later on. The diameter, the average diameter of the rocket is 0.06 meters. Now, the pre-ignition coast time will typically be 0. So pre-ignition, nothing's happening. Your launch begins when you ignite the motor, so that will be 0 seconds in this case, but when you have multiple stages, that will be different. Similarly, your post-burn coast time, since you only have one stage, the coast time after the first motor, and first and only in this case motor, burns out, we can just set that to 1,000 seconds to match the maximum expected flight time. Then we need to enter a value for the total inert or dry mass of the rocket. In this case for Alpha Centauri it's 2.4233 kilograms. And that is most of the simulation input data set now. You can then continue with the rest of the simulation, answer questions such as do you want to randomize the wind speeds, which drag calculation method do you want to use, do you want to import an engine file, will it import Rickrock again, and so on and so forth. And now, while the components are being listed again, we'll have a look at this simulation input data file we created, set number 3. And there's all the data. If we compare that with the original one, you'll see it's very similar. With the original one, the gust velocity was different, but aside from that there aren't too many differences. The numbers you see at the end are not numbers you enter yourself, they are calculated by the program and added to the file. Those are values such as the mass flow, the propellants out of the motor, and so on. And then you can just continue running the simulation as normal and get your results. And that's how you create a simulation input data file. In the next video, we'll create a rocket design data file.